We continue the conference with another session from Derek Lee. In today's session, he shows you how to set up advanced integrations with Logic Apps. This session is recorded earlier, and Beck Lyons is waiting for your questions in the Q&A. Over to Derek.
Hello and welcome to the third day of the conference and to the session on advanced integration with Azure Logic Apps. I hope you have learned a lot about Logic Apps and Azure Integration Service in general in the past 2 days. And in this session, we're going to turn it up to 11 and show you some of the more advanced things you can do with Logic Apps, patterns, tips and tricks, and the DevOps experience that I promised to show you in my earlier session. And we're also going to keep this session rather raw with minimal editing. I hope you like it, and let's get started. Let's start with some messaging patterns. With Logic Apps, we have a lot of customers use it to build workflows to handle messages. Messages that are in an Azure Service Bus queue or topic, or Azure queue, or LEMM queue, you name it. A lot of our customers use Service Bus. It is actually one of the most used connectors among the 400 plus connectors that Logic Apps support out of box. It has some great features such as first in, first out guarantee, and you can peak log on a message, do the processing, and then either complete, abandon, or dead letter the message. The problem with Service Bus though is that there is a file size limit on how much message you can, how much data you can have in the message. And we're talking about in the order of kilobytes. So what if you are working with messages that are larger than that, a few megabytes, for example? And this is where the first message handling pattern comes in, and it's called claim check. So what is claim check? Let's suppose we are some secret agent and we have to do a dead drop. Let's suppose we are a secret agent that have to give our handler some materials. We have a box of materials that we have to do the handoff, and we're doing this at a restaurant. The problem with this is that the box is just too obvious, right? Other people will notice when you hand off the box. So that's like the file size being too big. So how do we deal with that? One option is we can actually check the box in. So we can go to the concierge or the code check desk and be like, I have this box, can I check this in? And they will take it and give you a check, a claim check, of which you will be able to use to retrieve the box when you leave the restaurant. Only in this case, we are not going to be retrieving the box. We will instead take that ticket and give it to our handler. And then our handler will go retrieve the message. So in a sense, we're using the concierge as the intermediary for this exchange. Now, how does this work in Logic Apps and with Service Bus? Well, let's take a look. So suppose we have one Logic App. Maybe this Logic App will receive some data. And this data is the data that we want to include in the message, but it's too big. So what we can do is we can actually take this message and upload it to a blob storage. I'm using blob storage as an example, but you can actually use any other file store that would return you a pointer to reference that file and retrieve that file later. So the blob would give us a path to that file. Now we will then take that path and that becomes our Service Bus message. Because the path is only a pointer to the file, this is going to be very small and most likely under the file limit, the size limit. So we have another Logic App on the other side then, that will be triggered whenever a new message appears. It will read the path information from the message, and then it will go to blob storage to try to get the content. And then we get the content back. And this is the file that is over the size limit of Service Bus, but then we are still able to retrieve it by using blob as an intermediary, but still taking advantage of all the characteristic that service bus queue would afford us, such as first in, first out guarantee. All right, so how can we implement claim checks with logic apps? Let's take a look. I have two logic apps here. I have a claim check sender and a claim check receiver. We'll start on the sending side. The sending logic app has a request trigger, so we can easily trigger and test the logic app. And then we'll start by adding an action to upload the content of the request trigger to a blob storage. So we'll search for blob. And we will choose create a blob. I already have a connection created and a container called claim check. This is where we'll be saving the content to. The blob name, let's just give it a random name for now, and blob content will be the body of the request. So that's it for the blob action. Next, we are gonna choose service bus. And I want to send a message. Again, I already have a queue created called claim check demo. I don't need a session. I do want to include content. So instead of including the body of the HTTP request, which represents the actual content that we care about, we will use the path output from the blob operation. So this is essentially a pointer to the file that we have created. And that's it for the first logic app. Let's save it. And we'll switch to the receiving logic app. This logic app will have a service bus trigger to begin with. And we'll use when the message is received, autocomplete. We'll look into the same queue. And I will use the blob action to retrieve the actual content of the message. So here I'm gonna use get blob content using path. And the blob path will be the content of the service bus message. The content will come back as a binary, so I'm just going to use a compose action to convert that into JSON. So that is the second logic app. Let's save it and test it out really quick. We'll go back to the sender logic app. I will need to know the request trigger URL. And I can just go to my REST client to test it out. Now let's send in some content here. Oh, and it is post. All right, so the logic app should have been triggered. Let's go back to my browser and we'll check for a run. So I think the last one should be for the message that I just sent in. Let's take a look at each and every single action one by one. So this comes in representing the message. This is the path of the blob that we uploaded to. Again, this is the binary content. And here in Compose, we should see the actual message that we sent in from the VS Code extension. Cool. So that is claim check. The next messaging pattern that we'll look at is called sequential convoy. Now, when using service bus queue, chances are you will have different type of messages in the queue. An example can be for order processing. If we have a queue that represents things that we have to do to prepare and deliver an order from an e-commerce site, chances are there are multiple steps that you have to do for each order. Printing out the shipping label, printing out the invoice, get the package weight, get it picked from the shelf, schedule it with the carrier for pickup, so on and so forth. And then these tasks have to be repeated for each and every single order that you receive in your system. Now with logic apps, we often prefer to have a single logic app run that takes care of all the steps for a given order and only for that order. So let's take a look at how we can implement a sequential convoy to do exactly that. Now again, if we go back to our drawing board, if we imagine a service bus queue, we may have some circles, we may have some triangles, we may have some squares. So a particular shape would represent a given order, right? So square may be my order 1, and triangle may be my order 2, and square may be my order 3. Now what I want to do with logic apps is that I want my logic app run number 1 to pick up all the circles and complete it. And then I want to have my logic app run number 2 to pick up all the triangles. And then I want to have my logic app run 3 to pick up all the squares. All right. So the first message a given logic app run picked will determine which order it will be processing, and it will only be processing that particular order and nothing else. All right, let's take a look at implementing sequential convoy in logic apps. So here I have most of the logic already built. Let me walk you through what I have here on the workflow designer. Well, we do have to add a few more details just to make this complete. So here we start with a service bus trigger. We are using pclock to retrieve that message and place a lock on the session. All right, so we get message from my queue, and the session ID is the next available session. Next, I'm gonna initialize a variable. I'm calling it completed. It is a Boolean and it starts with the value false, meaning we haven't done finishing processing all the messages. Then I have a compose action that I take in the content of the message. This really just to indicate doing something with the message. For the sake of demo, I'm using compose, but in reality, you may want to send the message to somewhere else. You may want to transform the message and save it to some other places. Depends on exactly what you are trying to do. But here, we're going to use compose. Once we have done working on the message, the first message in that session that we have received, we are going to complete the message, indicating that we have done with it. All right, so complete the message, we need to supply the name of the queue, the lock token from the message of which triggers the workflow, and the session ID of where that message comes from. Now, this is the first place where I will want to add something. We'll actually add a parallel branch. Now, so with logic apps, you can have parallel executions of actions. And in this case, what I want to do is to actually add another service bus action. And I want to dead letter the message. Now, why do I want to dead letter the message? In fact, I want to go into run after and say if this failed or skipped or timeout for any reason, really, if it didn't succeeded, I want to dead letter the message. So this is my error handling, right? By default, it should go to complete, but if something happens, I want to dead letter the message so I can have another logic app that manage the dead letter queue. So again, I will choose my queue. I will use the lock token. Let's say it failed. And the session ID will be the session ID for the message from the trigger. So that's the first thing I want to add. Now, if it succeeded, what do I want to do? I'm actually doing a do until loop. So I want to do until this is true. So I want to keep looping until the variable changes its value from false to true. So what I'm doing inside the do until loop then, I'm doing a get messages from a queue p clock. So I'm gonna be getting it from the same queue. And we are only gonna be getting messages in that queue for this same session ID. We don't care about any other messages. Once I have retrieved all the messages in this queue that belongs to this session, well, actually, before I do anything, I'm going to do a condition to check and make sure I indeed retrieved some messages. So I'm checking the length of the array representing the message. I'm saying if it's not 0, then I'm going to start processing it. If it is 0, that means I have reached the end of the queue. I have exhausted all the messages. So I'm actually gonna set variable complete to true. All right, so this would terminate my do until loop. But here I'm doing a for each loop. I'm looping over the body, which is an array of messages. And I'm doing a compose again to indicate I'm processing the message. And afterwards, I'm completing the message. So here, what I would do is actually the same thing that I just did to add another service bus action to dead letter the message if I fail to process it. So again, same thing. I'm gonna skip the configuration, but again, just to show you that I can configure the run after to run it if the previous action have failed. And now I've reached the end of the do until loop. So here, the other thing that it's missing is after the for each loop, I actually want to also set the variable to true, or otherwise I'm gonna be stuck in the loop. All right, that's it. That is a logic app that would perform a sequential convoy messaging pattern on a service bus queue with session enabled. All right, let's switch gear a little bit and show you something in the local development experience that you may want to be aware of. One of the action logic app support is HTTP webhook. This is great when you want to implement asynchronous processing, where logic app would invoke an endpoint for it to do some work, pass in some data. The work may take seconds or minutes, hours, or even days. Logic app can invoke and supply a callback URL and just go into hibernation. The other service can do its work. Once it's completed, it can invoke the callback URL of the logic app that was supplied when HTTP subscribe call was made, pass the data back to logic apps, and logic app can resume execution with other actions that's defined in the workflow. The problem though is when you are trying to do this locally. If you remember my session on the first day, when running this locally, the host name generated will be localhost. That is obviously unresolvable when trying to call in from the internet, which the other servers may reside. So let me show you what that problem looks like, and then we'll take a look at how to fix it. So here I have a logic app. I have a request trigger, and I'm gonna use the HTTP webhook action. In this action, I'm gonna be doing a post to subscribe. And the endpoint that I want to subscribe to is another logic app that I have created on the cloud. So this logic app, just to walk you through briefly, it will receive the call from the subscriber, and then it's just going to immediately call back, pretend it finished the processing of the work. So here in VS Code, I will paste in the URI. And the subscribe body, I have to include the callback URL here. Just like so. Let me save the logic app and start a debugging session. So that is running. I'm going to go into the overview page for my workflow and copy the request URL and go back to my handy REST client. To invoke it. All right. Now, if I go to my logic app on the cloud, we see a run is happening and it is failing. It is failing with bad requests because it's trying to invoke localhost from the internet. That's obviously not going to work. So how do we fix this? So the tool you will need to fix this is called ngrunk or grunk. Ngrunk. Not sure exactly how you pronounce the name, but this is the tool that you will need. I already have it installed on my machine, and what it does is essentially creating a host name that is available on the public internet and then route any call that's sent to the endpoint to your local machine. So here I can go to command prompt and start it up. And I want to map any call to this endpoint to port 7071, which is the default port function runtime uses. And you can see here, it is forwarding this URI to my local host with this port. Now, what I can do here is to simply copy this and go back to VS Code. Here you see we have this nice notification to say, hey, configure the host for remote endpoint. And I can just paste that in. So now let me save the workflow and we'll restart the runtime just to be safe. And let's invoke the logic app, after which we can take a look at the logic app on the cloud. And it already succeeded. And if we go back to the HTTP action, we should see it is using the URL that we just input into VS Code. So that is how you do HTTP webhook when running and developing locally with the new logic apps runtime. A lot of the connector actions are actually also webhook based. So it is also useful for those actions, not just the HTTP webhook action that I used. An example can be event grid trigger, which we subscribe to a event grid topic and wait for the callback. The next thing I want to show is running the local runtime on a different port. Now, this is really useful when you have more than one logic app project that you want to run and debug locally at the same time. Or maybe you have a few logic apps project and some Azure function project, which also uses the Azure function runtime, obviously. When you want to run and debug things locally at the same time, by default, you will see a conflict when trying to start the second runtime, because they're trying to use the same port, 7071. You can change it, and let me show you how. So here in the task.json file under VS Code, you will notice a task called func host start. And it is as easy as doing an additional argument, -- port, and you can choose whatever port number that you want to that you want to use. In my case, I'm using 7074. So let me save this, and I'm gonna just start debugging again. And here, if you look at the terminal output, you can see that we are starting on port 7074. Right. So in this case, you will be able to have one Logic App project running on 7071, the next one on 7072, so on and so forth, and they will be able to run at the same time, and you can have Logic Apps and functions to invoke each other. All right, so let's do just that. I have on my machine an Azure function project on the left-hand side, and I have a Logic App project on the right-hand side. The Logic App project is what we have been working on. And the function project only has one function inside that would just return hello world whenever it is called. So I didn't change anything in functions. A function will run on the default port, which is going to be 7071. So let me start debugging that first. And here we can see the function runtime have started. Let's just call the trigger really quick to make sure it works. All right, so it looks like that works. Now I want to go back to my Logic App Designer. I already have a request trigger, and I'm gonna add an HTTP action to invoke my function code. It's gonna be a post. And I will just paste in the request URL here. So let me save that. We'll start debugging the Logic App here on the right-hand side. And you can see that it is using a different port number so that there is no conflict between the two runtime. And I can go back here and invoke my Logic App. I already have the URL from a previous run. Remember to change the port number. And the Logic App is triggered, and the function is triggered, and you can see that from the terminal output. So here, if I'm building an application that consists of a function app and the Logic App, I can now test both locally at the same time. But there is a problem, however. You will remember that in the Workflow Designer, I'm hard coding the endpoint for my Azure function. So I'm calling localhost 7721 HTTP trigger 1. That is going to be a problem when and if I deploy my function and Logic Apps to the cloud. I need a way to be able to substitute that. Between different environments, between different deployments, I want to use a different value. So I'm invoking a local function, and when I'm doing this locally, I'm invoking a function on the cloud when I'm doing this on the cloud. Which is a good segue into talking about DevOps experience with Logic App's standard runtime. Because the new standard runtime is built on top of Azure Functions, the DevOps experience is also very similar between Logic App Standard and Azure Functions. So if you have done any DevOps on Azure Functions, this should look very familiar to you. And to make this even better, we also published a set of templates so you can use those as the starting point for both GitHub Actions as well as Azure DevOps. Let me show you how to do this in GitHub Actions. So here on GitHub, under Azure/Logic Apps repository, we publish templates that you can use for your DevOps and CI/CD pipeline when running both in Azure DevOps, like I'm showing here, as well as when running this in GitHub Actions. Today, we'll focus on the GitHub Action aspect. We'll go into the GitHub/workflow folder. This is not the Logic App workflow, but rather the GitHub Action workflow. You see 4 files here. There are 2 that has container in them that will essentially package your local project into a Docker container and publish that to a container registry. And then we have the other 2 for deploying to Azure into app service using zip deploy. We'll focus on the zip deploy one for now. Why do we have 2? You can see the first one is called infrastructure as code deploy, And the second is called logic at deploy. And I want to spend a little while to explain why it is authored as so. When we look at a local logic app project, it consists of a few different things. You have your workflows, and you can have multiple ones with the new logic apps runtime, multiple workflows in the same logic app. And then you have other things, right? You have app settings, you have connection, and then you can also have parameters that we also introduced recently. And then you can have other things here. When we look at the resource in the Azure portal, it has a few more things, right? It has the logic app resource, which again have your workflow and a bunch of other things. It has a storage account, so the runtime can write states to, especially when you're running stateful workflows. Then you have API connection object. If you're using connectors, and you may have multiple one of these. Then there are connections between the two. Right? Logic app runtime needs to be able to access the API connection. So there is an identity aspect also between a logic app and the storage account. Now, when we think about CI/CD, the question we have to ask ourselves is that, do we want to redeploy everything that we are seeing here every single time a workflow is updated? And I think not. Ideally, I would want to leave everything that I'm putting a shade on intact. I really just want to do these once. Right? There's no reason for me to recreate the storage account. In fact, I'm almost certain I don't want to recreate the storage account because there are data in it. API connections, I don't want to have to reauthorize my API connections. So I want to deploy this at the beginning once and just leave it be. And again, all the identities to be able to, for logic app to access these things, I don't want to change it. So all that I want to do in my subsequent deployments are my workflows. And this is how we separate the templates. What you are seeing here is what we called infrastructure as code deployment. That set up the logic app resource, set up the storage account, deploy the connection, and make sure they can talk to each other. And then we have a logic app deploy that only deploys your workflows. And this is most likely what you will be changing and iterating on when you are developing logic apps. So let's take a look at these and see them in action. So here you can see I have the GitHub Actions from the sample template copied over into my local project. So what I can do is, let me do a git add, git commit, and a git push. This local project has already been configured to track an upstream repository that I have in GitHub, so I can just push all the changes to GitHub. So now let me switch to the GitHub repository, and I can go into GitHub Actions. Now for demo purpose, I'm configuring this to be triggered manually. In practice, you can obviously configure this to trigger whenever a new commit is pushed or whenever a new pull request has been approved. So let's go into the infrastructure deployment and run the workflow. And while this is running, let me just switch to my Azure portal and show you that I don't have anything in this particular resource group at the moment. Now, like I mentioned, this infrastructure as code deployment pipeline will set up my logic app, configure the storage accounts, create any connection, if I have any, and make sure they can all talk to each other. It will not deploy my workflow that I've implemented in my local project, not just yet. It will be taken care of by the other pipeline that will trigger shortly after once this is completed. All right, that has finally completed. It took a little while, but it succeeded. So now let's switch to Azure portal and check out what we have. So here's the resource group with the app service plan that represents the workflow standard plan, the logic app standard resource, as well as the storage account for the logic app runtime to use to preserve states. And like I mentioned, we don't have any workflow in the logic app at the moment because we are just setting up the infrastructure. But with the infrastructure set up, we can now trigger the second deployment, which will provision the workflow for us. All right, so now the second logic app workflow deployment have completed. Let's go back to the resource and find the workflow that we have built. So now it is up on the cloud. However, there's still one problem that we have to fix, and it is hard-coded function URL that, that wouldn't work once it is deployed. So how can we do that? We're introducing a concept called workflow parameters into logic app standard, which is the perfect candidate to solve this problem. Let me show you how. So here, back in VS Code, what I can do is to add a new file called parameters. And here I can define the parameters. I'm doing this in the code view, but the designer experience will be available very soon. We need two parameters here, type and value. And the value will be the localhost value. Now let me save the parameters file, and I will go back to workflow and change this to say add parameters . All right, so let's test this out really quick. I have my function running locally on the left-hand side, and I have my logic app, and then we'll run this on the right-hand side. The only difference is this time, it will be retrieving the value of the URI from the parameters and use the value at runtime. So let's try it out. So you can see the logic app is triggered. And from the terminal output, we can see that logic app invoked the function app and everything works. This is great. So we changed this value from hard-coded in workflow.json into parameters.json, but that doesn't really solve our problem when deploying to production. So there's one more thing that we have to do. So I am going to copy the parameters file. Let's change this to, so rename. How about we call it parameters.prod.json. Now in the prod version of the parameters, I'm gonna change this localhost to the actual URL of my function app. Now, I already know the value because the function app has been deployed, but the value can also be set during deployment time if you are doing infrastructure as code deployment for both local projects, obviously. So now I have both parameters file, one for my local testing purpose and one for production with the value that I want. The last thing I have to do is to update the GitHub action definition. And we'll be updating the second GitHub action, which, if you remember, will deploy my workflow implementation into the Logic App infrastructure that has already been provisioned. So here you can see one of the steps is to create an output folder and copy a bunch of folders and files into that folder. So what we can do is to add another line. So what we're doing here is we are copying the parameters.prod.json file into the output folder, but we are also renaming it to parameters.json, which is what the runtime will be looking for. So this way, when we deploy the workflow using GitHub Actions, it will ignore the parameter.json file that's in the GitHub repository, which is only used for local testing purpose, and will but rather grab the prod version, which will have the correct value. So let's commit the change, push that to GitHub, and see it working. All right, so let's check it really quick. Here I am in the Kudu console. So I'm gonna open the parameters.json file and just double check to make sure that it has the value that I'm looking for. And I'll go back to my workflow. So in the designer, let's double check to make sure that it is using a parameter for the URI. And then I will copy the workflow trigger URL and go back to my REST client in VS Code and send a request. Let's refresh. And we can see that it is making a call to my function app running on Azure using the value that we stored in the parameters file. All right, so this is everything that I want to show you in this session. Hopefully you will find this helpful. This is really just the tip of the iceberg of what Logic Apps can do. And now with the new runtime running on top of Azure Functions and inside App Service in Azure, it really opens up so much possibilities. So I encourage you to tune into other sessions during Integrate, and obviously feel free to reach out to us at any time if you have any questions, feedback, or concerns about Logic App in general. Thank you very much, and have a nice day.
convoy.co